Hello everyone! In this video, I will present different parallel programming models applied to matrix vector multiplication. We will explore how this problem can be implemented using OpenMP, MPI, and CUDA, and compare their characteristics. So, the chosen problem is matrix vector multiplication. We want to compute the product between a matrix A and a vector X, resulting in a vector Y. Each element of Y is computed as the dot product between one row of the matrix and the vector. An important observation is that each row can be computed independently, which makes this problem ideal for parallelization. So if you want to know more about this problem, you can watch my previous video. So, in the OpenMP approach, we use a shared memory model, where multiple threads run in parallel and share the same memory space. The most common way to parallelize this problem is by using a parallel loop, where each thread computes one or more rows of the result vector. So, this code here uses an OpenMP pragma directive parallel for to automatically distribute iterations of the outer loop among threads. So each thread computes a full row of the result matrix, and since memory is shared, all threads directly access the same arrays, A, X, and Y. So the main idea behind OpenMP is simplicity. Since all threads share memory, we do not need explicit communication between them. Synchronization is handled automatically. So, however, this also means that OpenMP is limited to a single machine, since all threads must access the same memory. Now, the MPI approach. In the MPI, we use a distributed memory model. Each process has its own local memory, so data must be explicitly exchanged between processes. For matrix vector multiplication, we typically divide the matrix rows among processes and then distribute the vector so that each process can perform its computation. So in this code, MPI scheduler is used to distribute parts of the matrix A to each process. Then MPI bcast sends the vector X to all processes, ensuring everyone has the required data. And after that, each process computes its portion of the result independently using its local data. So, the key idea in MPI is message passing. So, processes communicate by sending and receiving messages. This allows the program to run across multiple machines, making it highly scalable. However, it also makes the programming model more complex. The programmer must manage a communication explicitly. Now, let's see the CUDA approach. In CUDA, we use the GPU to perform the computation. The GPU can execute thousands of threads simultaneously. So each thread can be responsible for computing one element of the result vector, which enables massive parallelism. In the CUDA kernel, each thread calculates its global index using block index and thread index. This index determines which row of the matrix the thread will process. Then each thread performs a dot product between one row A and the vector X, storing the result in Y. So the main idea behind CUDA is to exploit the parallel power of GPUs. Data must be transferred from the CPU to the GPU before computation, once the GPU threads execute in parallel. This model can achieve very high performance, but it is more difficult to program and requires specialized hardware. Now let's see the advantages and disadvantages of each model. OpenMP is easy to use but limited in scalability. MPI is more complex, but it can scale across multiple machines. CUDA offers very high performances, but it requires a GPU and more advantageous programming knowledge. So a key difference between these models is the memory model. OpenMP uses shared memory, where all threads access the same data. MPI uses distributed memory, where each process has its own data. CUDA uses GPU memory, which is separate from the CPU memory. So, in terms of ease programming, OpenMP is the simplest. MPI requires more effort due to explicit communication. CUDA is the most complex. So, regarding scalability, OpenMP is limited, MPI scales very well, and CUDA provides massive parallelism on GPUs. Now, each model is designed for a specific type of hardware. OpenMP is used on normal CPUs. MPI is typically used in clusters or distributed systems, and CUDA is used on GPUs. So in conclusion, the same problem can be solved using different parallel programming models. Each model has its own trade-offs in terms of performance, complexity, and scalability. The choice of model depends on the available hardware and the requirements of the application. And understanding this difference is essential for designing efficient parallel programs. And that's it for today. Thank you for watching. Bye bye.